Hello and welcome to CP Rosefloat's tutorial on Labview. Last time we looked at what Labview is, some terminology with Labview, and also how we use Labview on our float itself. Just some basics are there, but this time we're actually going to dive into the code itself and learn some more basic terms and how to do some very simple coding. So let's start by opening up the program, and we're going to go to File, click New VI. In case you didn't watch the last video, VI stands for virtual instrument, and watch the last video to learn what a virtual instrument is. So if you use the shortcut Control T, it'll instantly snap these two items to the side of each other. But let's go over what each of these are. So right here on the left is the front panel, and on the right is the block diagram. I'm just going to expand the front panel first so we can just focus on that, and then we'll focus on the block diagram next. So Labview has two main parts, which appear as the two major windows, as you saw. The front panel is a window where you can create your own virtual instruments. Typically, this is where the user interacts with the program by entering data and viewing results. It is called the front panel because it's supposed to look like the front panel of an instrument or a group of instruments. The front panel virtual instruments generally come in two forms. User inputs are called controls, and the program outputs are called indicators. The front panel also includes non-functioning items such as free labels and decorations. Again, data is generally inputted to a VI program through a control, and processed data is output by a display on one or more indicators. In a little bit, I'll show you what this is, but first I need to teach you how to access these. So in order to place these control and indicators on the front panel, you'll need to access the control panel, or controls palette. You do this by right-clicking in the front panel window, so I just right-clicked right there, and this process is called popping up, and is used to access many of Labview's functions. So if I go here to, I'm going to actually make these side by side again, and if I go here to numeric, you can see how there's controls and indicators. So once again, the controls are the inputs, and then it will also appear on the block diagram. I'll go into the block diagram next. And I can also put in an indicator, and you also heard that there's another thing called labels. So basically you double left click, and then I can put whatever I want up here, like front panel and block diagram intro. And yeah, so I'll go into some more details on this in a little bit, but first let's go over to the block diagram. So the block diagram is a window where the graphical code is created. This is the programming that replaces text syntax in traditional programming languages. What you see in this window are icons called nodes. There are many types of nodes. First are nodes that represent controls and indicators. It's like you see right here. So this node represents the control that we inputted on the front panel, and this one right here, numeric 2, represents the indicator that we implemented on the front panel. And yes, so like I said, there are many types of nodes. First are the nodes that represent the controls and indicators on the front panels. These nodes are called terminals. In addition, the block diagram includes nodes that represent functions like add, subtract, compare, constants, and those are just to name a few. And program execution structures like while loops, for loops, and case and sequence structures. Most nodes are wired together for logical functioning of the program, and all nodes have one or more input and or output terminals called connectors to wire to and from. In order to place functions on the block diagram, you'll need to access the functions palette. This is very similar to the controls palette, how we did that on the front panel. You do this by right-clicking on the block diagram. So I'm going to right-click, and there we go. We got our functions palette, and we can do stuff like, if I go here to numeric, I can add this type of node called the add function, and I'll show you how to wire this up in a little bit, but basically that's how it works. So Labview utilizes what is called data flow. This is where a node executes its function only after it has received data from a previous node. After the node is through with its function, the processed data is transferred via the wire to the next node until it is passed all the way to the indicators on the right. There are several different types of data and where to carry the data, but we'll discuss these in a later video. So I'm going to go to the front panel here and add another control. because if you see right here, uh, on this node, there are multiple different places to connect. So I'm going to add a wire. Basically, just left click and drag where you want it to connect. I'm just going to connect these nodes, and then I'm going to connect this. So as you see right here, when I highlight, or I got to connect there, there we go. When I basically bring my mouse over the plus function, the addition function, it says x plus y. This top terminal, or this top space right here will be the x, and this bottom one will be the y, and the output will be our x plus y. So very simple math right there. And basically, that's one of the simplest types of code that I just created. I just created a very simple type of calculator. So I'm going to go back over here to the front panel and say, call this simple calculator. Okay, and we'll call this one right here our x, this one our y, and we'll call this one x plus y. And as you will see, before I go there, let me just show you how to align some things. So if you go up here to the right, you can actually align the objects. You can align them. Gotta undo that. If you go up here to the right here, you can see there's many different ways to align it. I'm going to align these about their center. And then I'm going to align these two right here along their vertical center as well. Oh, it already is. And I'm just going to drag this over to the middle. And there we go. Now it's all aligned. And as you will see here, I can basically add a number, 1, and if I run the program, it'll give me 1. Let's try it again. If I add a 7 here, it should get 8. There we go. Very simple programming, and it works. We'll need some more complex code here, but also I'd like to mention that there are debugging tools to help you in case you have a problem with your code, if you have an error, if it just doesn't work, and I'll discuss these in detail in a later video, but let me just show you a very simple case of it. So if I basically click on this wire and delete it, so like if you create a bad wire by accident, you can delete these and just rewire them. As you see here, the wire is broken, and also this arrow here that used to be continuous now is divided up, which will tell you, hey, your code's not working. So this is how it debugs. Then when you click on it, it'll give you these warnings, and it says here, add contains unwired or bad terminal. As you see, this Y part of the add function is not connected, so that's what that's telling us. And this one is saying wire has loose end. So it's telling us one of the wires is, and then the error with the wire. Sometimes it'll be like wire is the wrong type or stuff like that. So and also in the code, if it's a bad wire, you can see how it's turned to dotted with the X through it. So let's delete this wire. Gotta highlight it, delete, and wire it up again. And if you look at that broken arrow, it becomes whole again, and our code works. Just show it still works. There you go. Now I want you to pause the video in a second here when I tell you to. What you're going to do next is you're going to work on a little assignment, and we already have an addition function in this. I want you to try it out for yourself. If you don't have Labview, I recommend you downloading it from National Instruments. If you're a student, you can get a free trial of it, and so you can try it out and work with us as we teach you how to do this. I want you to create not only the addition that we have here, but I also want you to add an indicator for an x minus y, an x times y, and an x divided by y. Okay, so that's your goal. And before I let you go here, I'm just going to show you one more thing to do. You can actually wire on top of wire and split it. So if we had the subtract function right here, we can do that to the lower terminal. If we had addition function, we can bring the x down and do that to the higher terminal, if that makes sense. You can split the wires to multiple pathways. So I'll just show you what I'm talking about there. If I had the subtract, I can basically branch this off and branch this off right here. And now if I add another indicator on here and wire that too, or let me add an indicator over here. You can align all these later. If I change this to x minus y, and I wire the subtraction here, and when you run it, there you go. You got 10 and -8. So that's basically how you do this. So pause it and try it out for yourself. Then I'm going to show you how to do the rest. And you can also do aligning. But yeah, so pause the video here, try this out, and then when you think you got it, unpause it and I'll show you how you did. And that way you can compare it to how you actually do it and see how well you did. Yeah. So, so I hope it went well for you. And here you go. I'm going to add these two indicators on here. I'm going to just align them all so it looks pretty. You don't have to, but it makes it look better. Like I said, you also want to do X times, or yeah, so I'm just going to do a little star there, X times Y, and also an X divided by Y. And I'm going to wire these two really quickly. Get our X times, our X divided. We got to add the numeric nodes for the multiply as well as for the divide. And next we're going to branch off the wires, so don't want to move that. Got to branch it off. And that way it'll go. And remember, once again, Labview does use data flows, so how that goes on here is for all these functions, it will not execute the function until it first receives from the top part of it, like which is the X in our case, and then it next has to receive the next control, which is the Y. And it won't pass on the data to our indicator until it has received both sets of data from the two controls. Yeah, that's a very simple code, and when I run this program, you can see, you can check with the calculator, and it all works. So I hope you enjoyed this video, and in the next one, we'll be discussing more like data types, debugging, and other things like that.